Good morning and welcome everyone. I'm so excited to be here with you virtually at PyCon. This is Packaging Python in 2021. It's everything you need to know about the latest standards and how you can write easily buildable projects. I'll be detailing how to maintain explicit, predictable, and readable build information. This is information that can be used by both humans and machines to better understand your project. Today I'll be focusing on how to use the new pyproject.toml configuration, along with the modern build front-end back-end paradigm that comes with it. This file was first introduced into the ecosystem 5 years ago, but it's gone through some changes and has only recently been marked as a final standard. pyproject.toml is meant to hold core project metadata in a predictable location. It's not meant to be a blueprint that describes step-by-step exactly how to build your project. Instead, it's more of a sign that points the reader in the direction of some specific tools and other environment that the project needs to prepare its own blueprint. Although it might not contain enough information to completely build your project, whatever metadata is contained within should be treated as canonical for the project. Then the actual build tool specified by this file can come along and require additional configuration, either in the same pyproject.toml or its own configuration files. If you weren't aware, TOML stands for Tom's Obvious Minimal Language. It's a configuration format that's similar to YAML or INI. It's become a popular choice for packaging systems across many programming languages. However, it's not only build metadata that ends up in pyproject.toml. Despite that being its singular goal when it was conceived, having a single configuration file that's known to exist for all Python projects was just too attractive for many tool maintainers to avoid. And over time, space was made in the TOML layout for arbitrary Python tools to share and not conflict with one another. Some projects, such as Black, only allow authors to specify configuration in pyproject.toml, while other projects, such as iSort, allow the author to choose, either write the configuration in pyproject.toml and consolidate with other tools, or write it all out to its own tool-specific file. It is legal for pyproject.toml to contain this sort of tool configuration, but no build system. However, in this case, the project is treated as legacy, and to a build tool, it's the same as if it didn't have a pyproject.toml file at all. Here's an example of what a minimal pyproject.toml might look like. Notice in the middle, the project table contains only static data that is required to be part of any distribution, whatever its type, or whatever tool is used to create it. There are other possible project fields that can go in this table, but not all of them are required to be filled out. The project table is very new and not yet supported by all build tools. But look here in the future for where all projects might contain their core metadata. You can see lower down that the Black configuration is in the sub-table under Tool. Within this space, Black is free to define any interface it wants for its own options. Back at the top, you'll see the Build System Configuration table, where all the backend builder requirements are listed out, along with a single entry point into a specific build backend. A build backend might not be what you're used to selecting when defining how to build a project, but it actually gives you and your project's consumers more flexibility to choose the tools that everyone wants to use. What used to always be a single tool chain has now been formally separated into 3 categories. The old giant build tools would often lock downstream consumers, such as packagers, installers, or other maintainers, to always choose the same tools that the author used when first building the project. But these new categories, which interconnect through a set of standard APIs that are independent of any one project, allow each part to operate independently, even if in the end they are all defined in some larger project. There are three main tool categories used in turning source code into something you can import as a package. The build backend is the first. It turns source code into a distribution format, such as a wheel file. The project build backend is chosen by the project author and recorded in pyproject.toml. It's the only one of these tools that actually gets recorded. Next up is the build frontend, which handles user interaction. For instance, it might provide a command line interface, display progress to the user, or show errors from either bad metadata or problems on the build backend. Build frontends also must execute the backend in an environment that's actually suitable for building. So this could involve installing dependencies for the build backend, creating a virtual environment for it, setting its working directory, and other similar tasks. Although it's not very common, users wanting to build a project can select a different frontend than the author used, provided both that build frontend and backend respect these new APIs. The integration frontend is not actually involved in the build process per se, as by this point there already exists a built distribution file. But it does install this distribution file into your Python environment, and I think that's probably the most frequent way any of us actually interact with distributions, is by importing them. An integration frontend is capable of not just installing distributions, but also resolving that distribution's dependencies, possibly going out and finding them locally or over the internet, maybe downloading them, and then also installing those distributions. A project author has no control over what integration frontend is actually used to install a distribution. In fact, probably all public projects right now are being installed by multiple integration frontends. For many of you, there's just one tool that's done all these tasks, and that's pip. Pip often handles all of them for you at once and hides the complexity of having to do different jobs behind the scenes. Yet pip is not actually a packaging tool. Even though it's great, I believe its historic use as the one command line tool that's used to fulfill any kind of requirement for Python has blurred how Python used to see these different categories, and in some cases made it hard for them to see the need for them existing at all. So to show why pip was originally needed for Python, and why Python now needs to go beyond pip, we're going to take a brief look at how packaging has evolved alongside the Python language. It all started with distutils. Distutils was the original packaging library. It was released as part of the Python language in version 1.6. It also gave us the current setup.py convention at the top level directory to build projects. The common setup.py script can act as either a build frontend or a sort of integration frontend, as the CLI provided by importing distutils allows for both building from source and then installing that build into your environment. However, distutils did not originally allow any way to declare requirements, let alone go out and resolve those dependencies. So it goes a little beyond what a build frontend is, but not quite so far to be an integration frontend, in my opinion. Distutils, therefore, is kind of like a build backend for which you, as the project author, have to write your own build frontend each time as you write a new setup.py for every project. Also note that distutils has been marked deprecated in the latest version of Python, which definitely makes it not a good choice for new projects. After years of nothing but distutils, setup tools emerged on the scene as a popular placement that exists outside of the standard library. It continues the use of setup.py for all projects, meaning that project authors are still, to some degree, writing their own build frontends. However, setup tools also came with a script called easy install, which did act as an integration front end, and definitely a better one than calling straight setup.py scripts. It was capable of resolving dependencies and downloading distributions from pypy.org, which was originally brought online around the same time as Setup Tools' first release. Although Setup Tools was originally released to duplicate and extend all the functionality distutils had, its use as a front end of any kind right now is being actively moved away from. Much of the original functionality it first gave to scripts that imported it has been removed. Functionality such as running tests, or being able to declare requirements for setting up your code, or building your code using those special requirements, are all no longer supported. Soon, Setup Tools projects will only be able to be built when using a build front end that complies to the new front end specification. However, its use as a build backend is still very important and not going away. It's likely to remain at the core of Python packaging, just as a build backend. After Setup Tools, it's still another couple of years until Pythonistas finally get a proper integration front end with pip. Pip makes using projects easier by hiding the details of using many setup.pys directly in order to satisfy a set of requirements for a project. As a tool, it's definitely superior to easy install and acted as a full replacement, even if it would be a few more years until easy install was officially marked deprecated. Pip was also Python's first integration front end that allowed dependencies to be installed directly from VCS addresses. So you can thank it for being able to install that project directly from a GitHub link. Still, pip is not a build tool. It originally only knew how to build projects from source because it knew the special way to invoke a setup.py, which was the build front end. After the build backend was formalized, pip did then learn how to call build backends directly, which technically also makes it a build front end, but I think it's a pretty poor one as it's missing some important functionality you would want from a full build front end, like the ability to create sdist file distributions. So if pip already worked as a front end and Setup Tools is still working great as a back end, and they work together pretty well to do your building and installing, you might wonder why we're asking you to add yet another file to your projects. Especially if you stop to consider that pyproject.toml isn't actually replacing any of the functionality of either of those tools. Well, for a start, you'll be following the new expectations of consumers of your project. It's not just tools, but humans that work with your project are all now looking for that ubiquitous pyproject.toml when first getting to know your project. By including one, you as the project author are then free to change how you build your project without disruption to your users. Another important build problem that's solved only by the use of pyproject.toml is declaring what packages your project needs to start its build. I think PEP 518 best sums up the problem when it talks about setup.py's shortcomings. It's a catch-22 of a file not being runnable without knowing its own contents, which can't be known programmatically unless you run the file. Python has gotten a long ways by simply assuming that setup tools and pip are almost universally available, just like the math module. But both of these third-party packages have been deemed so important that they are in fact available upon a fresh install of Python or anytime you create a new VM. But it doesn't help you packaging if you decide to use a different build front end, or if you use a different build back end, or if you need anything more than just setup tools and pip to do your build, like if you need Python or wheels. Making pip and setup tools as available as they are has fixed a lot of Python's build bootstrap problems. At least it did until everyone decided that wheel was the newest standard and everyone should follow it. You see, pip doesn't really know how to install a package from source. It knows how to install a distribution. So if it comes across some source, it first turns that source into a wheel file. But the build backend that pip uses, most commonly just setup tools, doesn't know how to build a wheel file. It knows how to build an sdist file. So we need this extra package, which confusingly is also called the wheel package. You'll have noticed this oddness if you've ever tried to pip install from source a project that does not contain a pyproject.toml file. You can see here what happens when we try this in a fresh virtual environment. When we try and pip install, pip gives us a less than helpful error message noting something about bdist wheel not being a legal command, even though all pip was asked to do was just install some Python source code. If we look a little further up the stack trace, we see some of pip's secret magic. It's calling setup.py behind the scenes for us, but it's choosing to pass along this illegal bdist wheel command it then complained about later on. If you've seen this error before, you probably immediately recognize the solution. You need to download a package called wheel from pypy. Just having this package around will magically fix the pip command through the use of some special setup tools hooks during its installation. There's no change necessary to the setup.py file or the pip command that was chosen to run. But all this is a pretty confusing conclusion from an error about an invalid command that was not executed directly and which complained about something bdist wheel command, nothing about a wheel or a package in its error message. This confusion and probable Stack Overflow searching could have been avoided if this project just added a pyproject.toml with a wheel requirement. Doing so saves its users a lot of pain and frustration. So let's take a look at how we can make this pyproject.toml work for you in your projects. Using the modern configuration that is pyproject.toml not only lets you shed some outdated packaging practices, but gives you a lot of new advantages as well. Being explicit about your build backend will always get you the same build environment, always on your machine and in CI, and even on your users' machines, even if they choose to use a different front end than you did. It will also allow you to try out different backends and have to change very little or nothing at all about your code. And now that pyproject.toml is a standard, some build-related tools will only work on projects that have this file in their project at all. Similarly, more and more tools are adopting pyproject.toml as the location for their settings, even a lot of tools that have nothing to do with building. This makes for a lot less files overall in your project's top-level directory. So even if your project is building just fine right now, it's only doing so based on a lot of assumptions, and assumptions are no way to build dependable software. So go ahead and choose a build backend, and let everyone know what you chose by putting it in a pyproject.toml. If you're sticking with the setup tools backend, that's great. But even after including a pyproject.toml file, there's a few tasks you can do to even more modernize your packaging. First, stop using setup.py as a script for any of your tasks. It's no longer intended as any kind of front end, and whatever capabilities it does still have will be going away. Another advantage pyproject.toml can give is the ability to actually drop setup.py altogether. Instead, pyproject.toml and the setup.cfg files as static configuration can handle all of your build details for you. Then you don't have to have a build front end as part of your project with a setup.py script. A building tool outside of your project can handle all the building logic for you. Finally, if you keep your setup.py file and it's importing from distutils, switch that to importing from setup tools. You want to get away from this library before it disappears entirely from the Python language. If you maintain a project that doesn't have a pyproject.toml file right now, and you want to add one with the least amount of friction, just create it with these 3 lines. The legacy build specified here is in fact the exact behavior pip will give you if it comes across a project that is missing a pyproject.toml file. So adding this file will not change how your project actually gets built. And as a bonus, users of your project won't get confusing fetus wheel errors because they didn't have wheel ready to go for you on their machine. If you want to go further than just adding build information for what was essentially already happening, try moving to the standard Setup Tools backend entry point. Note that Setup Tools does not yet support project data in pyproject.toml, so you'll still have to use setup.py to specify metadata as configuration. If you don't already have one, try creating it and adding some core metadata there. Then try moving more metadata from setup.py into your setup.cfg. Before long, you may find that everything that originally you needed setup.py for can be moved to setup.cfg, which means your setup.py disappears entirely and leaves you and users of your project with only explicit, predictable, and readable build information. In the end, all users of this project will benefit from these changes. Packaging is a very rich landscape that's still evolving, so I encourage you to keep learning about it. There's a lot of great resources out there. These are some that have been helpful to me in forming this talk. Thank you and have a great rest of the conference.